Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT, from weatherist.com here in Central Virginia, talking about This Week in Weather. And we got a lot to talk about here for this Thursday, February 13th, 2025. We have another weekend rainstorm coming up, but more importantly, I want to talk about why this Ohio Valley Great Lakes low, which will be a snowstorm for those guys, sets up the February 19th and 20th East Coast snowstorm threat. Talk about the Phase 8 with the MJO Phase 1 from February 16th to the 28th. And then why the European, but not the GFS, is the model to follow for East Coast winter storms when you're dealing in the 84 to 216 hours. So 84 hours is day 3.5, or 3.5, out to day 9. Now, once we get within 72 hours, the GFS is a much, much better model. But in this time frame, we'll explain why. So it doesn't mean that the European is always superior. I'm not saying that, not at all. I'm just saying for the East Coast, it has a certain advantage when you're dealing with day 3.5 out to day 9. Okay. This here is the website, in case you haven't seen it, and there is your shop page. Okay, so here you can see, you get the 3-week newsletter subscription, you get the Mid-Atlantic forecasts, and you get our snow removal. So it's really good stuff, and also a lot of grain stuff from our grain traders. In fact, this is the grain weather page for the Twitter, and you can see right there. And then this here is a blue sky page as well. All right, now this here on the left, upper left, this is the latest edition of the latest 3-week newsletter, which came out on Tuesday evening, or early Wednesday morning, and you can see the different topics we have listed here. But the one here in the bottom right, this is from February, a week ago. So this is from February 6th, something like that, February 5. And you can see here that we were talking about, again, February, the middle of February here, with more events coming up here. So we've been talking about this for a while, this event, and it looks like it's going to be a pretty decent event. So let's get into it. Currently, our teleconnections here on the MJO, we are in Phase 7, right here in 7. This is the trace of the last since January 4. So as you can see, it's moving at a pretty good pace. Right through. We're not getting any of these little dipsy doodles where it stalls here. We're not seeing that. Now, interestingly, some of the models over the past couple of weeks have consistently tried to show these little swirls and twists and turns, but so far we're not seeing them. The MJO is moving at a pretty steady pace right through the different phases. Now, this is Phase 7, and this is your polar vortex, your dark purple area, your negative trough. And look at this huge ridge that you get in the jet stream when the MJO in the month of February is in Phase 7. You get this big ridge right here. Another ridge in the eastern Pacific Ocean. So that's what the pattern should look like. And in fact, when we look at the actual pattern, we'll see that in just a minute here. Here you go. This is the actual pattern. Look what we're seeing. Let me bring this forward so you can see it a little more. Boom. There's your big negative anomaly. There's your ridge on the East Coast. That's Phase 7. That's what that is. So that works out really, really good, especially when the MJO is strong. Remember, this is the weak circle neutral. So the closer it is to the circle, the weaker the impulse. The stronger to the edges, the stronger the impulse is. Okay, so here you go. This is the MJO for the European model. Now, the European model has it, as you can see right now, February 10th, 11th, going to Phase 7. And then it goes into Phase 8, February 15, 17, 19, 20, 21, then to Phase 1, and then curls into the neutral circle at the end. Now, just as a matter of regressing to the mean, the MJO impulses almost always, not all the time, but almost always, after day 15, go into the neutral circle. Okay, so just letting you know. Now, and of course, the yellow lines represent different perturbations or different individual members of the European model. Now, this here is the bias corrected. Now, this is different because here what they do is they take out the bias of the model over the past recent weeks. And what's happening here is that the MJO collapses right when it gets into Phase 8 and jumps into the neutral circle and bypassing Phase 8. Now, that would not be good for the East Coast snowstorm threat if that happens. Now, that being said, only the European bias-corrected model is showing that. The other models, especially the CFS, and this model's had the hot hand for the past 3 months, shows it clearly going to Phase 8 and then to Phase 1. in early March, and then drops into the neutral circle, or phase 2, after March 7th. And the Japanese model also, which is very good with the MJO, because MJO is so important in the Pacific and for Japan, also has to go into phase 8 and phase 1. And this takes us to February 23rd. So I don't think this is correct. I think this solution is correct. I think the CFS is the way to go here. That being said, let's take a look at this. In the month of February, when you have the MJO in phase 8, you get this huge block in Canada and northeast Canada and Greenland, and a very strong negative anomaly. The T stands for trough. The BK stands for block. And you can see it right there. All right, the jet stream is split. You have one branch coming down from the Arctic, the other one from the Pacific, and you get your big storms here. Now, this is phase 1. It's sort of a variation of phase 8, but not quite as strong, but there's still a strong negative anomaly on the East Coast, and you're still getting blocking in Greenland and northeastern Canada. So this also looks very promising in phase 1, and we get to that later on in February, early March. And the temperatures, you can see how it changes. Now, where we are in phase 7, with this huge ridge here, naturally it's very mild, and sure enough, that's what the temperature pattern reflects. And then phase 8, you can see how much colder the East Coast gets, phase 1 and phase 2, in January, February, and March. Okay. And what happens is, the reason for that is you can see the anomalies. When we are in phase 8, you can see this huge negative anomaly in the winter months on the East Coast. That's why phase 8 is often known as the big East Coast winter storm phase when that happens. Phase 1 also, to some degree, in phase 2, not as much. But definitely phase 8 and phase 1. All right, now let's take a look at our teleconnections. Teleconnections are significant relationships or links, connections between weather phenomena at various locations around the world, sometimes hundreds, if not thousands of miles apart. So the El Nino and La Nina, that's a teleconnection. The MJO is a teleconnection because it occurs in the Indian Ocean and along the equatorial Pacific and the Western Pacific, and it affects many, many areas around the globe. But in North America, we have 4 different teleconnections which affect the North American weather pattern. There's the Pacific side here on the red line, which is the EPO and the PNA, Eastern Pacific Oscillation and PNA. Then we have the Arctic Oscillation and the North American Oscillation on the Atlantic side. So let's take a look at it. So these are traces from various models. You can see here European High Resolution, European Ensemble, the GFS Ensemble, the European AI model, and the Canadian. So you can all see here what it's doing. So we're looking at the Atlantic side here first. This side right here, the Atlantic side, okay? And this gives an idea of how the pattern is shaping up. So when the Arctic Oscillation is, it's connected to the polar vortex. When the polar vortex is weak, or it comes south, the Arctic Oscillation is more likely to be negative. So a negative Arctic Oscillation favors below normal temperatures in the eastern U.S. and increases the storminess, while the positive Arctic Oscillation favors above normal temperatures in the eastern U.S. and less storminess. And it favors more for the western U.S. and the upper plains. So as you can see, the black line is what we have been seeing. So there you are in February, going down, 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 down. That's the bottom of the scale right now. The Arctic Oscillation is extremely negative. It's off the charts. Can you believe that? Now, as we approach February 19th and 20th, it starts coming up. And often when you get a big snowstorm, winter storm on the East Coast, the AO and the NAO will change phases. They'll go strongly negative, strongly positive, or strongly positive, strongly negative. That's a common characteristic. And here's the NAO, which is northern Quebec, Labrador, Greenland. All right? You can have a big blocking feature there or an upper low. When you have a blocking feature there, the Greenland block, that's called the negative NAO. And that's where we are right now. See how it's going down? Now, when we reach February 18th, 19th, it begins to reach its negative value and then begins to come up. All right? So this is very common with an East Coast big snowstorm pattern. On the Pacific side, we have the EPO, the Alaskan Ridge or the Alaskan Trough. And right now, we are in, you can see the black dots, we're negative, we just crossed into neutral territory. And then for the next 2 weeks or so, taking us until early March, we're kind of neutral with a slight general trend towards being positive. And then the Pacific, the PNA pattern, the West Coast Ridge or the West Coast Trough, again, negative PNA favors the West Coast and a ridge on the East Coast, and a lot of storminess on the West Coast and milder temperatures on the East Coast and the Midwest. But a positive PNA allows for a ridge on the West Coast and colder temperatures. So right now we're negative going to neutral, and then after February 20th, we kind of go positive here for a while. Okay. So this is the upper air pattern we just talked about, that this is as of Thursday morning. There you go. You can see it. All right. And sure enough, if we look at the surface map, this is the cold front, which is coming through right now, and the high pressure coming in behind it. Now, this next piece of energy in the off the coast of Washington State, that's the next rainstorm. But the cold front's coming through. Temperatures are much colder now than we saw. This is where we had the recent rain. This is last night, Wednesday evening. You can see the rain coming up, a little bit of freezing rain in the Shenandoah Valley, snow in the Midwest. And then this is early on Thursday morning, more rain in the Mid-Atlantic, the Ohio Valley, and then snow in the eastern Great Lakes up into eastern Ontario and Montreal. Okay, so behind the front, boom, high pressure comes in for tomorrow, February 14th. Nice in control, seasonal temperatures, no big deal. All right. Then we have the next system to worry about, which is the next rainstorm. Okay, so there's our ridge. Here's our 50-50 low, okay, for Saturday. And there's the next trough coming in. So low pressure is coming out of this trough, and it's going to track up. And this piece of energy right here, they're going to phase. Okay, and they're going to get this negatively tilted trough right here. That's going to drive the low pressure up Sunday night into the eastern Great Lakes, into southeast Canada, and this upper low is going to capture it. The surface low and the upper low are going to meet and have a huge party in southeast Canada. Let me show you what I mean. Okay, this is the rainstorm coming in for Saturday. Okay, we start off dry on the East Coast, but the clouds are coming in fast. You got rain in the Ohio Valley, snow in the Great Lakes, and then we look how warm it is in this pattern. So there's waves of low pressure going up the front, all kinds of heavy rain here in the Mid-Atlantic. Now, it might start off as snow Saturday night in northern Pennsylvania, up most of New York and New England, but it's not going to last, not at all. And the mild area is really flowing north here with this low. And let me show you, the low really intensifies. This low down here in Arkansas, becomes the big one, this one right here. And it comes up through the Ohio Valley, right up through the Appalachian Mountains, Pennsylvania, and you can see it goes over to all rain in the southern half of New England, southern New York. Upstate New York gets it. Ohio gets a big snowstorm. Michigan, the eastern Great Lakes, Montreal, northern Vermont, Maine, but everybody else is rain. And these temperatures really warm up here on Sunday on the East Coast. Let me show you what I mean. All right, this is Saturday night. You can see the wedge is still in place here. Let me blow this up so you can see it a little more. See, the wedge is still in place, right? The temperature, as you can see, down in the 30s and 40s here. But here comes the warm air to the south, and then when the warm front blows through, look at these temperatures take off here. You can up and down the East Coast. Look at this, all the way 60 into Philly. Now, I don't know how fast I think the front will get into New York and southern New England Sunday evening, but this is Sunday at 2 p.m. So we'll see. Now, eventually, the cold front sweeps through the East Coast, and the Arctic air comes racing in. Large Arctic high coming down, and you're getting these strong north winds. Look at these isobars right here. A lot of upwind bringing the cold air in. The low goes into the Gulf of Maine. It goes back over to heavy snow in upstate New York. Central and northern New England is going to get pounded from this system. Very nice. All right. Now, what happens is we get this feature next. Now, that system, this low, goes up into southeastern Canada, and it runs into the blocking pattern. So it becomes stalls. So this now is Sunday night, early Monday morning. You have 979 low east of Cape Cod. Then it goes into New Brunswick, 962. And then by Tuesday, it's in Newfoundland, Canada. It's this huge, gargantuan low, all the isobars, and you have the Arctic high now in Minnesota. So you have these howling north winds funneling in the Arctic air southward. And that sets up the East Coast snowstorm threat. Okay, so as I mentioned earlier, and I posted this on a Twitter page, and I made a big post about how the threat is growing, there is a significant East Coast snowstorm risk, which is high with this event. Okay, we call it SEX, significant East Coast snowstorm. There's also MEX, which is major East Coast snowstorm. And even, I guess, call it HEX. I don't like using the term, but historic East Coast snowstorm. But right now, we're just going to go for a SEX event. We could upgrade this. February 19th and 20th. The 500 millibar pattern is ideal. We'll get into that. The MJO is in phase 8. We'll get into that. Weak La Nina is neutral. That's neutral. It's not great, but it's not horrible. As long as it's weak La Nina, it's okay. The teleconnection phase change is ideal. We talked about that. And now the other issue, one thing here is February 19th and 20th. That is not a weekend. Most of the big I-95 snowstorms, over 85% of them have occurred on the weekend, either Friday, Saturday, Sunday, or Saturday, Sunday, Monday, that weekend. But this one's not. This is Wednesday, Thursday. And that kind of favors D.C., Maryland, Delaware, Virginia, North Carolina a little bit. So I just want to point that out to you. All right. Now, these are the temperatures Wednesday morning. Look how cold it is here. Okay. Yeah, it's 16 degrees in D.C., 19 degrees, Richmond, 22 in Norfolk. Pretty cold. 23 and 25 degrees in Raleigh. Single digits in Pennsylvania, the Ohio Valley. Teens in Kentucky. Again, single digits up and down New England interior, even sub-zero upstate New York, especially with all the snow cover coming in here. So you're going to have a lot of sub-zero readings. This is probably too warm. All right, the Arctic air comes pouring south, and of course, with strong north winds bringing in the Arctic air, this very, very cold air is probably getting pushed further south. So if anything, these temperatures might be a little underdone in the middle Atlantic region and the Ohio Valley. But we'll use them for a good working order. They might be underdone by a couple of degrees. All right, so here we go. Let's talk about this. Now, this is valid Tuesday evening, midday. This is the 0Z. No, this is the 12Z European Ensemble. It just gives us a general idea of how this is going to develop. There's your block. You see it? Monster block. And again, notice how that matches the MJO Phase 8. I mean, identical. Look at that. Amazing, amazing match. Okay. Now, there's the disturbance right here, the southern jet stream. You see how strong it is and over the southern Rockies? And there's your trough here. These two features, this trough in the northern branch and the southern branch, are going to merge onto the East Coast storm. How these two features interact determine whether the low is going to slide off the coast or come up the coast. All right? Now, that is Tuesday. Now, by Wednesday, by Thursday evening, February 20th, when the snowstorm is raging on the East Coast, the 50-50 low has moved from Newfoundland, Canada. That is why we call it 50-50. It's 50 degrees north latitude, 50 degrees longitude. That's why we call it that. Some meteorologists have called it the NF, Newfoundland low. Either term is perfectly acceptable. Now, by then, the 50-50 low has moved north of southeast Canada towards the tip of Greenland. But now the trough is in place, and the block is in Hudson's Bay, Canada. And as always the case, the more west the NAO is, the better for the East Coast snowstorm chances. You see how far west it is of Hudson's Bay. Not Greenland, not Iceland, Hudson's Bay. Textbook setup. And of course, there's the next system coming in behind it on February 20th. Now, here's the GFS. This is the European, one last shot of that. No, and there is, okay, we looked at that. Now, here is the GFS solution from the GFS ensemble. February, again, 2 o'clock, 18Z, Tuesday, February 18th. Same as this. And what I wanted to point out here is the difference. You see the short wave here in Colorado and New Mexico? Look how weak it is on the GFS. Much weaker. This is why you can't trust the GFS on East Coast winter storms, because it doesn't handle the southern stream energy well. It doesn't handle it well. So as a result, the lows always come out weaker or flatter when they come off the East Coast. Now, once you get within 72 to 84 hours out, the GFS suddenly gets a clue, goes, oh, look what I'm seeing. Southern stream energy, and now you have a different map. So right now, you can use the GFS if you want to. I wouldn't. I just don't. That's me. I've been doing this a long time. I just avoid it. I look at it, of course, but it's not my primary model. And the time frame from 84 hours out to 216 hours out, day 9. It just isn't. All right. Now, if we look at the operational European from this morning, there's your shortwave. Look how strong it is here. Look how strong it is here. See that southern shortwave? That's much, much stronger than the GFS. There's your monster block, negative NAO. There's your 50-50 low. There's the northern trough. Okay? These two features are going to merge. And when they do, you get this. A closed 500 low in Minnesota that's negatively tilted, diving towards Kentucky, okay, the trough axis. And now you have a big storm. The 50-50 low is pulled away a little bit, up towards Iceland. I don't know if it's going to move that fast. It usually doesn't. And as a result, you get this solution. Notice the howling winds here. This is now still the evening of the 18th and the 19th. See the strong north winds still funneling the cold air into the mid-Atlantic from New England. There's your Arctic high, 1055 millibars in North Dakota. Wow, strongest Arctic high of the season, I believe so far. Maybe the second strongest. There's your low in Texas. Look at the heavy snow in Oklahoma, the Texas Panhandle, Kansas, Missouri. Getting blasted. blasted with snow. And then down here, now this is now Wednesday night, early Thursday morning. This is from the 0Z Thursday European. Heavy snow in Kentucky, Tennessee, Memphis getting pounded. Big snowstorm there. St. Louis, Indianapolis, Dayton, Ohio, Columbus. You're getting ice in western North Carolina, southwest Virginia. The snow spreading into central Virginia. You have your Arctic high here. And then you have the baby high over Binghamton or maybe Ithaca, something like that. And there's your cold air wedging coming down the coast. And then finally, things really kicks in here. Now, at this point, you have ice in central Virginia into D.C., into southern, okay, and the heaviest snow is inland. Because the low, look where the low is, it's in Norfolk. That's too far inland, right? And this would imply that perhaps the rain snow line would get into New York City. And then it moves off the New England coast. Now you have all snow in New York and New England and upstate New York. You got a blizzard up there, very nice storm or major snowstorm. That's the 0Z European. It's probably wrong, and I'll explain why. So, but the temperatures, you can see the 850 temperatures. Now, at the start of the event on Wednesday morning, you can see Richmond is, let me blow it up so you can see it a little bit here. Okay, -5, Norfolk is -1 or 2. That's all snow. This is all snow at the start of the event. Raleigh's -1. Okay, and then according to the morning European, the rain snow line goes north of Richmond. Again, up towards that way. Maybe that's true. I don't think it is, and let me show you why. Here is the operational European. Big snow, northwest half of Virginia into D.C., decent snow there. Baltimore, big snow in Hagerstown. Charlottesville gets 8 inches. Harrisonburg, the Valley, West Virginia, Pennsylvania, New York, New England, all great snow. New York, great snow. But the ensemble doesn't show that. See, this is very different from this. The snow is much further to the south and east. Very different. So the ensemble says this is wrong. Okay. I'm just letting you know what it's showing. Okay. Now, this is the 6Z European AI, and you can see that. And again, the low is further off the coast. And it's much colder in Virginia. You can see it clearly doing off the coast here. It does not hammer New York, upstate Pennsylvania, or New York or New England. I'm not saying it's right. I'm just showing you what it's doing, okay? Now, here is the 12Z European. Oh, look at that. Further south and east. Pounds all of Virginia. North Carolina gets the freezing rain. All of West Virginia, Eastern Kentucky, Virginia, Maryland, Delaware. Pennsylvania, New Jersey, the Delmarva get pounded. Major snowstorm. Does it reach as far north as New York? Probably. How much snow in New York and southern New England? Don't know that yet. 850 temperatures are much colder here. Notice the rain snow line is now just barely gets into Sandbridge, Virginia. Most of Hampton Roads, Williamsburg, Newport News stays all snow if this is right. So does Richmond, so does the Delmarva, so does southern New Jersey, so does D.C. and Charlottesville and Danville and Greensboro and Lynchburg and so on and so forth. And then it goes off the coast here. The dark blue is heavy snow, so you can see the heavy snow gets into Philly and New York and Connecticut and Boston, but the heavy snow stays out of northeast Pennsylvania, upstate New York, and interior New England. And there's your snow shield, like this. Okay? General idea. Don't get too excited about this. We don't know if it's going to be, it could be, I think it's going to be more than this. If this track is right, I think this snow is underdone, but let's just go with it. Get an idea. Now, here's the European ensemble. You see the lows here? The model is showing the low all on North Carolina coast moving off the coast. Not up the coast, moving off the coast. Here's the European ensemble QPF with the rain snow line. The black line here from early Thursday morning, that's the rain snow line. You see how it barely gets up towards Norfolk and then drops down again. So all this green stuff is snow. And the total accumulation, 0.8 of an inch in Richmond, for example. All right, 6,500s in Charlottesville and D.C., okay, 6,500s in Roanoke. Now, at a high snow ratio because of Arctic air, that's not just 6 or 8 inches, that's probably closer to 10 or 11. And then south and east of Richmond, it's even heavier if it stays all snow. Now, this map here shows the chances of getting 6 inches or more of snow on the 0Z European. Okay, see that orange area? That's very close to the Richmond metro area into the Tappahannock. That is a 60 to 70% chance of 6 or more inches of snow. Okay. Now, this is the 12Z Thursday afternoon European. You can look how many more lows we have here. See how much stronger the signal is? The European is detecting it. It's seeing it. So this is what it was showing this morning. This is this afternoon. Okay? And again, moving off the coast a little bit. Great news for North Carolina, western North Carolina, Virginia, Maryland, Delaware, southern New Jersey, southern Pennsylvania, maybe West Virginia. Not so great for New York and New England. And then you can see the amount, again, the QPF. Same thing as what we saw before. Here, let me shrink this down. This is 0Z, this is 12Z. Almost identical. 0Z, 12Z. 0Z, 12Z. Okay, good. Now, this is the GFS from 6Z. Right? Again, this is valid Tuesday, February 18th. And we saw that the low here is much weaker. I have the low there. You can see it's much weaker here. So it doesn't pick up southern stream systems. It never has. Now, the solution here, this is the 6Z GFS. There's the low. Nice snow in Virginia, Maryland, Delaware. Okay, up the coast. And then along the New Jersey, New England coast, but nothing north of that. This is a very viable solution. I don't have a problem with it. I just think it's a little underdone in the southern stream energy, so I think it's suspect. Okay, here's the 12Z GFS. There it is. Nice snowstorm developing in Tennessee, Kentucky, Virginia, West Virginia. You get a little bit of ice, okay, along the North Carolina-Virginia border. Not major snow in central and northern Virginia, into Delaware, coming up the coast. You can see the low. Arctic high is here. The baby high is here. Class of signature. And there it is. This is Wednesday night. Not a weekend, Wednesday night. Okay, southern New Jersey, reaching up, just up to New York City into Philly. Maybe Allentown, maybe as far inland as that, but not much. And then southern New England out to sea. You can see the lows headed out to sea at this point. See that? It's headed out to sea. Just like we saw on the European solutions with the European ensemble. That's pretty consistent. All right. The GFS and the 12Z snow mounts map looks like that. The operational, the ensemble does not. Look how much weaker the ensemble is here. Now, why is the ensemble so much weaker? Okay, than this. One of the reasons is because the ensemble doesn't have a signal. This was the 0Z GFS. All right? And you can see nothing. No low pressure areas here at all. Now, here's the 12Z. It's still very, very weak. See how weak it is? No really lows here at all. And you compare that to the European. Again, like I said, this time frame from 84 hours out to day 9, the European does much better with East Coast winter storms because it detects the southern stream energy. I'm sorry, those are the facts. You can clearly see it. Okay? This is nonsense. It's way too weak here. Here's the Canadian. Canadian model is doing the same thing. Has a lot of precip. This is now Wednesday evening, and then Wednesday evening to Thursday evening. Yeah, you can see when you add these amounts together, 0.25 at Richmond, for example, 0.55, that's about 75 hundredths. Same thing as Charlottesville, same thing in D.C., same thing as Roanoke, same thing in Norfolk, in Raleigh, Greensboro, Salisbury. It amounts to the same amount of precipitation. And the Canadian also has a better organized low off the North Carolina coast, giving a signal here. And the snow map looks kind of like what we saw with the European. Kind of looks like that, as you can see in the European here. So there's the European and there's the Canadian snow map for what it's worth. Okay. Now finally, last slide, last picture here. This has gone on long enough. This is the event for February 26, 27. Some of the models had it on the 25. This one has it on the 26th. I'm not certain yet. All right. And this, now what's interesting about this is that there's no 50-50 low here. The NAO's gone positive. The Western Ridge is collapsing. So this would be the last event. I don't know if this is correct or not. This is the European operational model. The ensemble is colder than this, but I just thought I'd post it. The main focus here is going to be the February 19-20 event. And once we get past that, we'll talk about the potential event for February 24-25. So don't take this with a lot of any validity here. This is just showing something on the East Coast, and that's all we're going to mention about that. Okay, this is meteorologist DT from Weather Risk. I will see you over on the Weather Risk website, the Facebook page, and then on the Blue Sky page.